Hi guys, today we are solving the next task. It would be the most classic one. It calls container with most water. So we are given an array of heights of length n, and there are n vertical lines drawn such that the two endpoints, i's, there are I0 and I height. So we have to find two lines that together with the x-axis from containers such that the container contains the most water. And we have to return the amount of water a container can store, so that you may not slant the container. All right. All right. So here, for example, we have some points, and we see that we have 7 multiplied by 1, 2, 3, 4, 5, 6, 7. It would be 49. So the container would be 49 gallons of water. If we have container 1 at 1, like this one, we should, the container would be 1. So how can we solve it? By understanding, I understand. So let's find some constraints. So we have some high lengths. So I expect that we have at least 2 points, because with 1 point it's not valid. 2 points of our array, and here we have like 10 in the 6th power, let's say. And also I expect that every value would be from 1 to, let's say, 1000, something like this. Let's check if my constraint is correct. Okay, so it's almost correct, and here it's also almost correct. So it's like 1, 0 here and 1 from here. Let's think about solutions. Solutions. So the first solution that I can see that we can have, for example, 2 pointers from both sides. So let's say that we have this height, and we determine 2 pointers. So pointer 1 would be here, and pointer 2 would be here. And on each position, we should calculate how much water we should take. So we take the minimum and the distance between these 2 pointers. And then if we check 2 values, we should move pointer that is minimum. So here we have 8, right? So we again calculate, and then we move this pointer, calculate, and here we have 2 pointers that are the same. So if I move, for example, this pointer, it would be 6, right? So, and if I move this pointer, it would be less water. But it would be less water. But again, these 8 are bigger. But what if we have something like 9, right? And I move here, and then if I move here, and if I have 1, for example, right? So it's better to move by 9, but still it would be less than this 8, right? So I think in this case it doesn't matter actually where I remove next, and and just checking. So in this case we have 2 pointers, so the time complexity would be linear, and we don't need any additional space. So let's solve it. So we have result, we have left pointer 0, and we have j pointer. It would be height, length, minus 1, and while j minus I is greater than 1, we calculate, and at the end we return results. So what do? We take h and I, and we check if h and I is, first of all, we should calculate. So we calculate, so it will be results on mass maximum between, here it will be mass minimum first, and here we should take left and right. So we check left or right minimum, multiply by j minus I, and and here we take result. So we update our result. Then if our left is greater than R, then we should move some pointers. So if left is greater than R, then we should move our J, otherwise we should move our I. And return result. Let's check. All right, so here we have 1 and 1. So here we also should return the mass maximum between results and these calculations. Result and 1. Yeah, because it will be always 1. Okay. Okay, so we can have 0 water. Yeah, so then in this case we should do these calculations. So we take minimum between hi and hj, we multiply by we take 2, right? By 1. Okay. Okay, so we are done. Right, so this one is working, but as we see that it's slow one. Can we somehow improve this? Okay, so as you see, this improvement looks like just iterating by 1, and they're missing actually these calculations. They're missing this one actually. So that's why it's faster. Okay, but the idea, I think, is the same. All right, so that's it for today. Thank you.